Hi, today we're going to look at solving simultaneous equations where quadratic equations are involved. So if you have a look at this example, it's got a linear equation here, so x plus y equals 5. And in our second equation, it involves an indice squared, so a quadratic equation. And this involves using a different method. So the previous 3 videos on simultaneous equations, both equations were linear. There were no indices involved, and the easiest method to use is the elimination method, and that's what I was using in those videos. Today, because we have quadratic equations, we are actually going to use the substitution method because it's really difficult to eliminate a letter using the elimination method when there are indices involved. So in the substitution method, what we have to do is use one of the equations to change the subject into either one of the letters. So either the x or the y is our subject. Now, the easiest equation to change the subject to is always the linear equation. So this first equation here, x plus y equals 5, this is the equation I'm going to use to change the subject. So I'm going to make y the subject, and I'm just going to subtract x from both sides. So if we have a look at the equation, it's x plus y equals 5. Because I want to make y the subject, I'm going to subtract x from both sides, and I'll end up with 5 minus x. Now I'm choosing to make y the subject because in the second equation there's just one single y here, and it makes sense to replace just that y with what I know y is equal to. So I know y is equal to 5 minus x, so I can replace this y in the equation with that expression. You can make x the subject, but in this particular example, it would have been a little bit more hard work. There would have been more involved because we would have had to square that expression. We would have had double brackets, and it just meant taking a little bit longer to solve the equation. So that's what I've done so far. I've made y the subject. So that was step 1. Now we're going to substitute. So I'm going to substitute y equals 5 minus x into the second equation. So I've got 2x squared plus xy equals 14. And I'm going to substitute that in. So 2x squared plus x times 5 minus x equals 14. So the only thing that's changed is this y, because I'm replacing it with this 5 minus x, and that's what I've done here. Okay. Once you've done the substitution, we're now going to expand and simplify. Okay, we're going to expand the bracket and simplify the equation before we solve it. So I'm going to have 2x squared plus x times 5, 5x, x times minus x squared, still equal to 14. Try to remember this 14. It's a common mistake that's made. People tend to forget it's there. And because they forget it's there, they tend to just write that 2x squared plus 5x minus x squared. And then they panic because they no longer have an equation and they've got an expression, so they're not sure what they're doing. So please remember both sides of the equation. So because I've expanded the bracket, now I'm going to simplify. I've got 2x squared terms here. 2x squared minus 1x squared leaves me with a single x squared plus 5x equals 14 still. Okay, so now you can see we have a quadratic equation because the highest indice is 2. So we've got an x squared here. And because we've got a quadratic equation, This will now link back to the work we've done over the past couple of weeks with quadratics. So when you've got a quadratic equation, remember the first thing you've got to do is make sure it's equal to 0. So make it equal 0. And so that's what I'm going to do here. I'm going to subtract 14 from both sides. I've now got x squared plus 5x minus 14 equals 0. And now I can attempt to solve the equation. Because I've got a quadratic, remember there are 3 methods to solving quadratics. The first one is factorizing. The second one is the quadratic formula. And the third one is completing the square. Now, with this example here, I'm going to factorize. And the reason for that is because in the question, it doesn't say to give my answers to 2 decimal places. And that's the biggest hint whether or not we need the quadratic formula or completing the square. Now, there's nothing stopping you from using the quadratic formula. Just work it out. Your answer will probably turn out as a whole number, and that's totally fine. I find it easier to do factorizing if I don't need to have any decimal answers, and that's what I'm going to do here. So I'm going to factorize. I know it's a double bracket because I've got an x squared. So I've got this x squared term and this minus 14. So I've got to do 2 double brackets. Remember, it's still equal to 0. X and x makes the x squared. 2 numbers that multiply to give me 14. So we're going to look at our factors of 14. 14 and 1 and 2 and 7. So remember, I want them to times together to give me negative 14, add together to give me 5. I want to create a negative as well, so I know I'm going to have a positive number and a negative number. Okay. So 14 subtract 1 isn't going to give me 5, so I know that factor's not going to work. But I do know 2 and 7 is going to create a 5. I want a positive 5, so that must mean I want a negative 2. So I know the 2 is going to end up here with the negative bracket, and the 7 is going to be in the positive there. Remember, when we're solving quadratics and we've got a bracket, we want to make each bracket equal to 0. So x plus 7 equals 0, which means x is equal to minus 7. And then the same with the second, x minus 2 equals 0. So that means x equals positive 2. Now, you can see here that this isn't just as straightforward as the previous simultaneous equation questions, because we've actually got 2 solutions. We have a solution where x is equal to minus 7, and we have a solution where x is equal to 2. And this is going to happen quite a lot because we have an x squared in our equation. When we've got quadratics, we tend to have 2 solutions. That means we're also going to have 2 y solutions, and it's important to keep the pairs together. So when x is equal to minus 7, there will be an equivalent answer for y. When x equals 2, we're going to have an equivalent answer for y for that one. And I'm going to work out both separately. And this is where we go back and we substitute to work out our y. Now, I'm going to substitute into the first equation. This makes a heck of a lot easier to find y to substitute into the equation that's linear rather than the x squared. And you can see by the simplicity of the equation that number 1 is going to be a lot easier. Number 2 is a lot more complicated to work out y, and you want to make your life as easy as possible. So my equation is x plus y equals 5. Substituting the x for minus 7 plus y equals 5. That means I'm going to add 7 to both sides. And that means y is equal to 12. Okay, so that's the first answer. In the second one, again, I'm going to substitute into the first equation. X plus y equals 5 again. This time it's 2. 2 add 3 equals 5. So I know y is equal to 3. If you want to, you can then substitute both of these back into the second one to check if your answers are correct. And then when you're presenting your solutions, make sure you write them as a pair. So my answers are going to be x equals minus 7 and y equals 12. And then my second pair, x equals 2 and y equals 3. Okay, so solving simultaneous quadratic equations is very challenging. It does take a long time. So if you notice, I've done quite a lot of working out. I've had to rearrange and make y the subject initially at the top there. And once I've done that, then I substituted y into the second equation so that I have the same letter throughout that equation. I then expand and simplified the equation, realized it's a quadratic, so then had to make it equal to 0, which I've done that. I then double checked the question that it's not asking for any decimal places, so I factorized to solve. So I factorized my quadratic and then solved each bracket, realized there's 2 solutions to x, substituted it back into substituted it back into the first equation to work out my y values. It does take quite a long time, but in an exam, this question is worth a lot of marks, anything from 5 to 7 marks, depending on how complicated the equations are. So even though there's a lot of work involved and a lot of method involved, you are given the credit for that method. Work your way through this example from the video just to have a try, following my steps in the video as well, and then have a go at the knowledge organizer. Thank you.